Hi again. Lots of videos today. So number 3 on the chapter 1, 2, 3 review portion of your exam review has a section on just solving by algebraic methods. Again, this is essentially review material, but it's review material that a lot of us need, so that's okay. One of the skills that I want to make sure you have is being able to handle all these kind of fractions in your solving, because sometimes they're going to come up. And the tool that's good to remember here is your clearing fractions. You got a lot of fractions going on here, and it would be handy if they were out of our way. The denominators are 3's and 5's, so if we wanted to actually build a common denominator, 15 would be an obvious choice, but it's a lot of work to build up that common denominator. Another thing you can do with that 15 is if you multiply both sides by the common multiple of the denominators, what the common denominator is, that 15 is something that all of those 3's and all of those 5's can divide into evenly, and it will make all the fractions go away. When that 15 multiplies into the first term here, the 3 divides into the 15, leaving a 5 times 2 is 10x. When the 15 distributes here, 5 divided into the 15 is 3 times 2 is 6. The fractions are gone. 15 multiplies by the 1/3. 3 goes into 15. 5 times 1 is 5x. When the 15 multiplies by the 1/5, 5 divided by 15 into 15 is 3 times 1 is 3. So that one step of multiplying by 15 clears out all of your fractions, hence it being called clearing fractions, and gives you a much nicer thing to solve. So it's a nice technique. You'll see us use it a lot. So then you can solve this in your normal way. Subtract the 5x from both sides, get 5x minus 6 equals 3. Add the 6 to both sides. Again, I'm hoping we're happy with these kind of solving skills, so I'm doing it very quickly. So we get the nice solution, x equals 9/5. Yay! But that tool of clearing fractions is really, really useful. You can get this result by kind of brute force moving the fractions around and getting common denominators and fighting with it. And it's not so horrible, but it's a really nice skill to have, particularly when things get more complicated, and they will. So that was 3a. 3b, x minus 1 minus 2 equals 4. Okay, so this is another just, solve this equation. Should be a type of thing you've seen before, but you might not have done it in a while. These are the kind of things that we want to make sure we're fresh on. So one of the pieces of advice I give a lot for solving is you want to make sure both sides of your equation are fully simplified before we start using a lot of solving techniques. This equals 4. This 4 is perfectly simple. It's just a 4. But there's a lot of things we could do on this side to help simplify this out, so we should do those. Distribute your x, so you get an x squared minus x minus 2 equals 4. Now we have a nice quadratic, but to solve a quadratic, we really want it set equal to 0, not equal to 4. So x squared minus x, subtract that over, minus 6 equals 0. So we really want those quadratics set equal to 0. Now that a quadratic is set equal to 0, to solve, our two main techniques for solving quadratics that are set equal to 0 are factor it if possible, quadratic formula if not. So we do want to try to factor it. If your factoring skills are not solid, practice them. You'll need them. X's make an x squared. This might be, a 3 and a 2. We got to make a -1, so how about a -3 and a +2? Cool, we have a factored form. And the reason we wanted this set equal to 0 is because we needed this product equaling 0. The zero product principle, you may recall, says that if a product equals 0, the parts must equal 0. For something times something to be 0, one of the somethings has to be 0. So this is going to be true when x plus 2 is equal to 0, and when x minus 3 is equal to 0. So x would have to be -2, and x would have to be 3. And you can kind of verify that for yourself. If x is -2, -2 plus 2 is 0. 0 times anything is going to be 0. At 3, 3 minus 3 is 0. 0 times anything is 0. So those are your two nice solutions. That was B. Again, we want to be able to do that. And you could have used quadratic formula as soon as you have it at equal to 0. You could have used completing the square, too, if you wanted to. Of course, quadratic formula mimics completing the square, so I would tend to like to see you use quadratic formula as opposed to completing the square. But I like a good completing the square as much as the next guy. But you want to be trying your factoring. Factoring is generally faster and more accurate once you're practiced with it. Okay, C. C is nice and fun. X squared over 2 plus x plus 2/3 equals 0. Again, this has an ugly x in it. Sorry about that. Again, this has a lot of fractions in it. Well, not a lot, but enough. And getting rid of the fractions is often nice, and that clearing fraction technique will work just as well. The common denominator here would be a 6, so I'm going to multiply both sides by a 6, and that should destroy all of the fractions. When the 6 multiplies by that first term, 2 goes into 6 3 times the x squared is 3x squared. When the 6 distributes to the x, it's just a 6x. When the 6 distributes to the 2/3, 3 goes into 6 2 times 2 is 4. And be careful here, 6 times 0 is 0. You see a lot of people end up with a 6 here. It almost feels like you're cheating, isn't it? You multiply this side by 6 and nothing happens over here. That is the fun of the zeros. Anyway, now that we have a quadratic set equal to 0, we can try to factor it. So we spend a little time trying to factor that. But I don't think that happens to be factorable. 3 times 4 is 12. 2 and 6. No, I'm not seeing factorable. So spend a little time, moment or two, trying to see, hey, can I factor that? If not, quadratic formula is a great tool for us. So quadratic formula, it might be nice to know what its discriminant is. You might remember the discriminant is the b squared minus the 4ac. I talked about that in one of the quizzes. So 36 minus 4 times 3 times 4. So that's 36 minus 48. So your discriminant is negative 12. That means we're not going to have any real solutions. So if all we want is real solutions, we're done. No real solutions. Go on with your day. For this exam, unless otherwise stated, I kind of want the complex number solutions. Well, I don't kind of want. I do want the complex number solutions. So we should keep going. The quadratic formula says negative b plus or minus the square root of b squared minus 4ac, but that's our discriminant, over 2a. So that'll be, what, negative 6 plus or minus the square root of negative 12 over 2 times 3. And again, that's why I think I showed you this on the video for the quiz, why I like doing the discriminant first, because then you can just plug the discriminant in. But however you like handling your quadratic formula, it's up to you. It's your quadratic formula. Have fun with it. So negative 6 plus or minus, there's a 4 in there, so 2i square root of 3 over 6. There's a 2 in each of those terms. So how about 3 plus or minus I root 3 over, it's a lot of 3's. That's okay, who doesn't like 3's? Don't forget my negative, though. Because, yeah, we're taking a 2 out of that, and that, leaves a 3 there, and a 3 there, and a 3 there. Okay, I'm fine with that. Lots of 3's. So, again, quadratic formula is one of those things you want to have at your disposal. If you don't remember your quadratic formula, learn your quadratic formula. It's not going to go away. It's going to come up a lot. And it's one of those things we need to know, and we need to know it fairly quickly because it's going to be such a bread and butter tool. Okay. So, basic solving, A, B, and C. The idea with these solvings on your test, by the way, is to go here. You should know how to solve. Here are some points for it. It's a lousy place to miss points. It's one of the places I'm trying to give you points for knowing some of your basic mechanics. So make sure your basic mechanics are nice and strong. Fence problems. You will see fence problems and these little building wall problems all the time. I think I've mentioned this again on that quiz that you had. You've got 2,300 feet of fencing. I think I gave you a long talk on the quiz about this being a metaphor for restricted resources and so forth. If you haven't watched those videos, by the way, go watch those videos. So you have a 2,300 feet of fencing. You want to enclose a rectangular playground that has been subdivided in the way depicted in the picture. So it's got one horizontal and two vertical internal fences. So our fence has to make up all the outside and inside fences. And we want to express the area of the playground as a function of this dimension x. Again, this is a type of problem that you will see fairly often. Now, there's a couple different ways to set this up, but either way, this 2,300 feet has to come from a certain number of widths and a certain number of lengths. And we are eventually, in this problem, I believe, express the area. So our goal is to express the area of this playground. So it might be nice to recall that area equals length times width here. So that length times the width is going to be our area, but we have to get that down to just one variable x. So it might be nice to express these lengths. But either way you want to look at it, this 2,300 feet has to come from 1, 2, 3, 4 of those x values plus 1, 2, 3 of the lengths, and all of that has to add up to 2,300. Those 4 vertical pieces plus the 3 horizontal pieces has to add up to our total fence length. This is our relationship between our x's and our l's. So if we want to find our area, that area should be, pick whichever one you want to call x, call the width x, and this our length L. That L is going to be this relationship. So solve that relationship for L. Divide by the 3. Now you can think of this in a couple different ways. If you wanted to figure out how long this was going to be, if you were actually building this and wanted to figure out how long this would be, and you knew this length was, say, 20 feet, well, what would you do? You'd take your 2,300, you would subtract that 20 feet 1, 2, 3, 4 times. You'd take your 2,300, subtract 4 times that value, and then whatever's left, you would divide into the 1, 2, 3 pieces. So your original length minus these 4 pieces divided into 3 chunks. So however you want to go about it, we need to build this relationship. Once we know that that's L, we can put that L back in to our expression for area. Our length is going to be 2,300 minus 4x over 3. That's our length times that width, our x. Now our area is 2,300 minus, 2,300 x, as we distribute that x, over 3, minus 4x over 3. I'm basically breaking this 3 up into both parts. And don't forget to distribute that x. So I kind of did 2 steps there. I broke this into 2 terms and distributed the x among those terms. But the key is we now have a quadratic in terms of x for area. So the statement expressed the area of the playground as a function of one of the playground's dimension x. This is an expression for the area in terms of one of the dimensions x. We'll then ask to find the dimensions that maximize it. Well, this is a quadratic. It's got an x squared. Coefficient is negative, so this is going to be some sort of downward facing quadratic. Its maximum area is going to be its vertex. So we should know how to find the vertex of a parabola. The nice thing is we have a nice tool for that. X value of the vertex should be negative b over 2a. So your b, negative 2,300 over 3, over 2 times your a. Your a is your coefficient of your squared term, so it's the negative 4/3. And then evaluate. You might not like your fractions in there, but multiply by 3 over 3 kills both of those fractions, and you get the negatives undo each other naturally. You get 2300 over 2 times negative 4 is, well, after the negatives go away anyway, it's 8. So whatever 2300 divided by 8 is going to be this length, which will represent the width of our playground. You want to find the other side of the playground? Take the 2300 over 8, whatever that number is, and you could simplify that fraction even, and put it into here to find the other dimension. You want to find the area, multiply them together. Or plug the 2300 over 8 into your area formula. So once you get one of the dimensions, you actually have a lot of choices. But the maximum value on that area function is going to occur at x equals, was that going to be 1,150 over 4? You can still simplify it. Whatever that number is, 2300 over 8. I know you wouldn't leave an answer like that. It's a word problem anyway, so you'd answer it in a sentence, right? But hopefully that gives you the setup for those types of fence problems. And again, you saw in your section, I think this was 3.2 or 3.3, somewhere in there, where sometimes you'll have, these fences up against barns or up against rivers, or sometimes you'll have cost functions in them for how much the different outside and inside walls cost, all kinds of different variations. But all those variations are variations on this theme, and variations on the theme of maximizing limited resources. So practice those. You will see those types of problems over and over and over and over again. Okay. It's hard to do these fast. You guys should let me know whether or not you like the little things that I'm trying to add in here in the little perspectives, or if you just want me to race through these. If I go through them faster, it might be a little easier to save you time, but you might like the little extra details I'm trying to give to you. So let me know. So in what number are we on here? 5 on the 1, 2, 3 review section. Given a quadratic, you're asked to find y-intercept, x-intercept, vertex, and to sketch the graph. Again, these are all things we hopefully should be able to do. And again, I'm almost trying to throw some points at you here for knowing your fundamental skills. We've already talked on these videos about finding y-intercepts. Y-intercepts always happen where the x is equal to 0. So you want to find a y-intercept, let x be 0. Q of 0, it's negative 0 squared plus 3 times 0 plus 10. So the quadratic evaluated at 0 is 10. So your y-intercept is 0, 10. And that's it. To find x-intercepts, set the whole function equal to 0. Negative x squared plus 3x plus 10 equals 0. A lot of people tend to set quadratics equal to 0 just automatically, almost for no reason. Setting a quadratic equal to 0 really is specific to trying to find our x-intercepts, or what's called our roots or our zeros. But sometimes we have other goals. Sometimes we want y-intercepts. Sometimes we want vertices. Sometimes we want other points. So be careful about arbitrarily setting it equal to 0. That will give you your x-intercepts. I don't like this lead negative out there, so I might divide both sides by -1 just because we can. X squared minus 3x minus 10 makes it a little easier to, if you're going to throw it into the quadratic formula or factor it, it makes it a little bit easier to work with. Again, quadratic set equal to 0, so factor it if possible, quadratic formula if not, or completing the square if you can't remember quadratic formula. This is very factorable, I think, yeah. So be sure you're using the factoring when you can. You'll notice the factoring is a lot faster and tends to be more accurate. So do try to do that. So factor it, set the pieces equal to 0, solve. We have, that should be a -2. We have our two solutions, so those are our x-intercepts. So our x-intercepts are 5, 0 and -2, 0. You do want to express x-intercepts and y-intercepts as points. because that's what they are. They're the ordered pair that are on those particular axes. Vertex, part 3, finding your vertex. The x value of our vertex can be found with that negative b over 2a. We've seen that a couple times on this exam. You can also find it by completing the square and building the vertex form. If you'd prefer to do that, go ahead. But you don't have to. If you know the negative b over 2a relationship, you're certainly welcome to use it. If you're having trouble remembering that relationship, if you remember the quadratic formula, that negative b over 2a is the first part of the quadratic formula. They're both built from completing the square, so it's not a coincidence that that negative b over 2a and the negative b plus or minus the square root of b squared minus 4ac over 2a have some of the same pieces in it. They are both built from completing the square, so they're both coming from the same place. But that can sometimes, noticing that relationship can sometimes help people remember the vertex formula. Anyway, our b is negative 3, so negative 3 over 2 times our a is 1. So the x value of our vertex is going to be at, looks like 3/2. Great. That's not our whole vertex. Our vertex should be an ordered pair, 3/2 and something on the y value. Well, if we have an x value and want the corresponding y value, we generally find it by plugging back into the equation. So go back to the original function here and find what q at 3/2 are, or is. So negative, don't forget that negative, 3/2 squared plus 3 times 3/2 plus 10. If you don't like your fractions, practice with your fractions. They're not going to go away. Negative 9/4 plus 9/2 plus 10 is, what, 9/4 plus 40/4 is 49/4. Why does that look weird? I don't know, it just does. So 49/4. So that's our vertex. Again, you can also find that by building the vertex form of your quadratic if you prefer to use completing the square to do so. If so, great. I might recommend having both tools in your bag, but which one you use is up to you. We do want to graph these things. Make sure when you draw your graphs, you have axes on your exams usually, but you do want to label them some. The scales on them can vary depending on what you're doing. We want to put that y-intercept at 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0, 10. Don't do that on your test. Make sure your scale's nice. Sorry. Anyway, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5, negative 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. So we have our x-intercepts were at 5, 0 and negative 2, 0. We had a y-intercept way up here. Our x-intercept is at 49/4. A lot of people will ask me, I don't know where 49/4 is on the graph. Well, sure you do. That's 12 1/4. I mean, we don't like to use mixed numbers, but they're nice to use to kind of figure out where we are. So, boy, that's going to be up there. It's making me really not like my graph, my picture. Oh, well. I'll get over it. Just don't do that on yours. So 3/2, 49/4. 3/2 should be 1.5, so it should be right there. And you've got a nice parabola. You can even graph this other point over here. Stretch this over to here. It's still going to be at a y value of 10, but it's going to be over 3.5, over another 3.5, so that's going to be the point 310. Finding that symmetric point is actually really handy sometimes. I'm not going to ask you that on a test, but it's a good thing to know how to do. It gives you the 5-point classic plot of a parabola. So again, you want to be able to find x-intercepts, y-intercepts, and vertices of parabolas. If you can't, make sure you figure out how. And if you need help with figuring out how to do that, let me know. Come by my office. I don't see a lot of you guys in my office. I get all lonely in my office. Come by and see me. Did that sound creepy? Anywho, 6, getting down to the wire here. Oh, I should start 6 on another video. Boy, lots of videos.